Okay, well, so today we are going to discuss applications of Bernoullies principle. So in last class, we discussed how the Bernoullies principle equation came. So today in this class, we shall discuss some of the applications of Bernoullies principle. So some of the applications of Bernoulli's principle are, so how the Bernoulli's principle equation comes. So in last class we discussed that one. So in today's class we shall discuss some of the applications of Bernoulli's principle. So that is applications of Bernoulli's theorem, or you can call that one as Bernoulli's principle. So some of the applications of Bernoulli's principle are, first we are using in case of Bunsen burner, and second we are using this principle in case of lift of an airfoil, and third next we are using in case of spinning of a ball. So this effect, this is also called as Mangus effect. And next is we are using next application in case of in the sprayer. So sprayer works on the principle of this Bunsen burner. Next we are using in case of ping pong ball in the air jet. So there also we are using this application, and next application, this principle we are using in case of Torricel's law. This Torricel's law is also called as the speed of flux. And next, this we are using, this Bernoulli's principle is also used in case of venturimeter. And next, we are using in case of during windstorm, roofs of houses are blown off. That is based on the principle of Bernoulli's theorem only. Next, we know it is dangerous to stand on the edge of a platform while a fast moving train crosses on platform. So this also works based on the principle of Bernoulli's theorem itself. So next we shall discuss one by one. So how the way we are using. So we know we have this Bernoulli's theorem we are using in different situations. It is used in Bunsen burner, and it is used in lift of an airfoil, spinning of a ball. It is also called as Mangus effect. And this theorem is used in case of a sprayer, and ping pong ball in the air jet is also working based on the principle of Bernoulli's theorem. And torricells law, it is also called as speed of flux. We are using Bernoullies principle in case of torricells law. And venturi meter is also working based on the principle of Bernoullies theorem only. During windstorm, roofs of houses are blown off. That is due to based working on the principle of Bernoulli's law only. And we know it is dangerous to stand on the edge of the platform while the fast moving train crosses on platform. So that also works based on the principle of Bernoulli's theorem. So we shall discuss one by one. So this is the first application we are using the Bernoulli's theorem in a Bunsen burner. So let us, in Bunsen burner, how it is useful. So let us discuss in case of Bunsen burner. So we know when a gas, in case of Bunsen burner, so when a gas passes through a nozzle, the velocity of gas increases and the pressure inside the vertical pipe decreases. Therefore, air from outside rushes into the burner through side hole. So this mixture of gas and air moves upwards, which burns at the top of the burner. So here, the diagram of Bunsen burner was like this. So here, this is the Bunsen burner. So that is shown here. So in the figure 6, Bunsen burner is shown here. The diagram, the flame here is shown here. So due to the presence of gas, it is burning. And second one, we shall discuss about lift off and airfoil. So lift off and airfoil. So the diagram is shown in the figure 7. So already it is shown here. So this is an lift off an airfoil. So that is shown in figure 7. So this is the Bunsen burner. Bunsen burner. So that is shown here. So how lift off and airfoil works? So this is also work based on the principle of, so which one? So that is Bernoulli's theorem. The shape of an airfoil is such that it is slightly convex upwards and concave downwards, that is already shown here. Therefore, air passing over the top of airfoil travels a longer path than the lower surface in the same time. Thus, velocity of air above the airfoil is more than the velocity of air below the airfoil. Hence, according to Bernoulli's theorem, pressure on the upper surface of airfoil is less than the pressure below it. So this pressure difference provides the additional thrust on the foil. The vertical component of the truss provides the lift and the horizontal component provides the forward drag to the airfoil. So the diagram of an airfoil is shown in figure 7 here. So next application we shall discuss. So that third one, that is spinning of a ball. So spinning of ball is already shown here. So spinning of ball, so that is also called as Mangus effect. So here the diagram of spinning of ball that is shown in the figure 8. So here in this situation there is no spin of the ball takes place, and here spinning, while spinning velocity decreases and pressure increases. So that is shown here. So here velocity increases and pressure decreases. So spinning of a ball. So here let a ball moving to the right be given a spin at the top of the ball, that is shown in the figure 8 here. Velocity of air at the top is higher than the velocity below the ball. So according to Bernoulli's theorem, pressure above the ball is less than the pressure below the ball. Thus, there is a net upward force on the spinning of the ball. So the ball follows the curved path. So this effect is known as Mangus effect, we are going to call. So this is all about how the spinning of ball takes place and what is the reason. And next we shall discuss about next application. So that is one note point you have to remember. So bullets are made cylindrical instead of spherical shape. So why they are made spherical? Because in such cases, Mangus effect will be absent and the bullet will continue to move along the straight path. That is the reason you have to keep in your mind. So next we shall discuss next application, how the Bernoullies principle used in case of a sprayer. So the sprayer that is shown in the figure 9. So this is sprayer. So here this sprayer is also working on the principle of Bernoulli's principle only. So here how the sprayer works means the forward stroke of the piston produces a stream of air past the end of the tube that is shown in the figure 9. So the other end of the tube is immersed in the liquid. So that is shown here. It is another end tube is dipped in the liquid here. So the air flowing past the open end of the tube reduces the pressure on the liquid. So the atmospheric pressure acting on the surface of the liquid forces the liquid. So that forces the liquid here. So that is all about the sprayer. So into the tube D from which it is carried away by the stream of the air. So this is the working of sprayer. And next we shall discuss about next application, that is, so we shall discuss next application, that is fifth one. So that is fifth one, a ping pong ball in the air jet. So ping pong ball that is shown here. Ping pong ball, it is shown in the figure here. So the diagram of ping pong ball is this one. Ping pong ball diagram, this one. So this is an air inlet. So light ball here, it reduces the pressure that is shown with the help of arrow mark here. So let us see how ping pong ball in the air jet works. So a ping pong ball can be held in position in air jet that is shown in the figure 10. So in the space between the surface of the funnel and the surface of the ball, pressure is less than the atmospheric pressure. So this pressure difference produces a force which supports the ball. So this is one of the application we are using, or that is working based on the principle of Bernoulli's theorem only. And the speed of flux and Venturi meter. So those are also working on the principle of Bernoulli's principle itself. And next application, that is so eighth one. So we discuss some of the applications. So that is Bernoulli's theorem. It is used in Torricel's law, Venturi meter working based on the principle of Bernoulli's theorem only. Next we shall say during windstorm, roof of the houses are blown off. What is the reason? Let us see. So during windstorm, the velocity of above the roof is larger. So according to Bernoulli's theorem, the pressure just above the roof is less than the pressure below the roof. Due to this pressure difference, an upward force acts on the roof which is blown off without damaging other part of the house. So this is the reason for during windstorm roof of the houses are not blown off. And next application, that is, it is dangerous to stand on the edge of the platform while the fast moving train crosses on the platform. So let us see why it is dangerous. So it is why it is dangerous means when the fast moving train crosses a person standing near a railway track, the person tending to fall towards the train. This is because a fast moving train produces a large velocity between person and the train, and hence pressure decreases according to Bernoulli's theorem. Thus, excess pressure on other side pushes the person towards the train. So it is advised not to stand on the edge of the platform while fast moving train crosses the platform. So this is the reason why it is dangerous to stand on the edge of the platform while fast moving train crosses the platform. And next application, that is, we shall see applications of Bernoulli's principle where we are using is, so next application, so Bernoulli's principle we are using in case of, so next we shall see the meaning of dynamic lift. So the meaning of dynamic lift is, so dynamic lift is the force which acts on the body such as airplane wing and hydraulic fall and spinning of ball by virtue of its motion through a fluid is called dynamic lift. And next we saw the what is the meaning of Mangus effect, and here how the Bernoulli's principle is used in case of blood flow and heart attack. So how it is applicable? So Bernoulli's principle helps in, now we are seeing Bernoulli's principle how it is useful in case of blood flow and heart attack. So how it is useful, let us see, in case of blood flow and heart attack. So how it is useful? So Bernoulli's principle helps in explaining blood flow in arteries and heart attack. So due to bad eating and less physical work, accumulation of the plaque on inner wall of the artery takes place. As a result, artery gets constructed. In order to drive blood through this construction, a greater demand is placed on the activity of the heart. When the activity of the heart increases, speed of the flow of the blood in the artery is rising. So according to Bernoulli's principle, pressure inside the artery becomes low and may collapse due to external pressure. So the heart exerts further pressure to force the blood through that artery. As a result, the blood rushes through the opening and internal pressure once again drops due to the same reason. So this will be leading to the repeat collapse of the artery. So this may result in heart attack. So this is also one of the application of Bernoulli's principle. So here we discussed different applications of Bernoulli's principle. So it is used in blood flow and heart attack. How it is used for this principle, and ball moving without spin and ball moving with spin. So what is the meaning of Mangus effect? How this principle is used in case of venturi meter and speed of application. So different kinds of application we discussed in today's class. So here try to practice these. And based on this, if you are having any doubt, just put in the chat box.